In today's video, let's compare the SmartShunt 500 amp battery monitor with the Lynx Shunt 1000 amp battery monitor. As I said, these are both battery monitors. They're going to use a shunt to measure the current going in and out of your battery bank to give you the remaining state of charge or let you know how much fuel you have left in the tank, so to speak. Beyond that, they are not very similar. So let's dive into some of the differences. First off, I'll say the SmartShunt 500 amp unit is made to be kind of a standalone item. Oftentimes, people that do not use Victron's systems will use this battery monitor because it's going to be programmable and monitorable with your phone. So you're going to use the Victron Connect app to program it as well as look in on it and see what your data is saying about your battery bank. So you don't really need any of the other Victron items. Now, as far as the Lynx Shunt, that is mainly used with the Lynx distribution system. As you can see, I have a Lynx distributor there on the end. They also have the Lynx Power In. This is where your batteries can come in. It's got places for up to 4 batteries, and these are modular, so you can expand them. If you need additional connection points, you can keep expanding them and just make a whole row. I use the Lynx distributor in a lot of systems now because it's got 1000 amp bus bars and it's got some built-in fuse blocks as well, so it's very convenient. And so I linked up the Lynx Shunt to add that battery monitoring, and as you can see, it just beautifully bolts right onto the distributor. Now, as far as programming that, you're going to need a GX device. So I have the Ekrano GX here. You can also use the Servo GX, but you're going to do the programming and the parameters about your battery bank in the GX device. So that does not have Bluetooth, and you are going to have to use this UTP cable and plug it into the VE.Can port on your GX device in order to do that programming. So that's one of the differences. Got to have the GX device, and you really need to have the Lynx distributor at a minimum because it would be kind of awkward to use the Lynx Shunt with a bunch of free-floating cables like this. So it's made to bolt together in that Lynx distribution system, and it's a great addition to the Lynx distributor. Now, I want to mention, I'm going to zoom in on the screen here, and I want to show you an interesting finding that I found that's going to help you determine which one of these is going to be right for your project. I do want to continue and say they both have a temperature sensor. I've got them actually on different poles of the battery here. The negative one is running over to the Lynx Shunt. The positive is going to the SmartShunt and is also providing power to the SmartShunt. So we'll be able to compare their connections to the GX device. They will both hardwire to your GX device and show up as your battery on the bottom left of the screen. And you can also connect your GX device to the VRM portal to monitor or manage or monitor your system remotely. So it will report your data over time. You can look at graphs of what your battery bank is doing and what the rest of your system is doing. So either the SmartShunt or the Lynx Shunt will have its data. Whatever is connected to here, it will be exported to the VRM portal if you want to do that. So they're equivalent in that regard. They're both taking the battery temperature. They use different cable types to plug into the GX device. This is going to use a VE direct cord, and this is going to use a Victron UTP cord. And you have to use this little VE.Can terminator here and also on the back or where you plug into your GX device. And I also want to mention that the Lynx distributor is great as a standalone item, but it's supposed to give you warning lights when a fuse blows. So as you can tell here, it's got some red lights going. I left one of the fuses loose, so it thinks that the fuse is blown, and it's giving us a red light there. And you can see this little RJ10 communication cable hopping over to the Lynx Shunt. I want to mention, in order to get the Lynx distributor to light up like that, you have to connect it to the Lynx Shunt or the Lynx BMS. Now, let me give it a distinction. The Lynx Shunt and the Lynx BMS typically get sandwiched between the Lynx Power In and the distributor. So the power in does not have any fuse locations, and it's going to be where your batteries are going to connect, and then they're going to run through either the shunt or the BMS to get to the distributor, and that's going to measure everything between the batteries and the rest of your system. So it's a very clean setup. With the BMS, you're going to use that with the Victron Smart Lithium batteries. They have those little black communication cables, and those cables are going to plug into the bottom of the BMS. The Lynx Shunt, like I have here, is made to be used with other battery brands that have an internal BMS, such as this Lifetime battery, or even the Victron Super Packs that have that internal battery management system. You don't have an external battery management system because that's all done in the top of the battery. And so in that case, you just need that shunt to measure the current coming and going from your battery bank. So that is kind of a rundown of how they differ. They're going to be measuring the same parameters. So as far as the programming, it's going to tell you the last time you had a full charge, how many full cycles the battery bank has gone through, the highest voltage, the lowest voltage of the battery bank, things like that. So the parameters of both of them are set by Victron, and they are identical. I do want to mention a couple of additional features with the Lynx Shunt. So in addition to the temperature sensor, which you can see here, it also has a spot for a main fuse. So even if you have little fuses on each battery coming in, when it runs through the Lynx Shunt, you can have a main system fuse there, and it will also report whether or not that fuse is blown to your GX device, and it can set off an alarm. It also has an alarm relay here and can do things like start a generator, or it can also be manually controlled in your GX device, or from the other side of the world in the VRM portal, you can pull up your screen here, go in there, click the button, and turn on the relay in the Lynx Shunt, and whatever you have it connected to is going to turn on. Could be a light, could be an engine starter, but it's going to activate that relay from the other side of the world with your manual input, or if it has an automated alarm setting, it will trigger the relay when that alarm condition is met. So the relay and the main system fuse are not part of the SmartShunt, so it's a little bit more feature rich than the SmartShunt. Now I want to mention on the fuse, let's give a few pointers on that. I have an A&L fuse there, and it is rated at a maximum of 32 volts. So both of these battery monitors, the Lynx system as well as the SmartShunt, they can all do 12, 24, or 48 volt battery systems. So my fuse maxes out at 32 volts. So if you do a 48 volt battery system, you would want to go with a C&N fuse. And those go up to 80 volts and a maximum of 800 amps. So that's what you would use for your main system fuse. And as you can see, as I have it here, you don't have to have all of the Lynx items. I don't have the Lynx power in for my battery power coming in here. I've omitted that. I've just got a terminal fuse on this battery, and then I've used regular 4-aught cables to come in and bolt onto the Lynx system. So you can do a mix. You don't have to have it completely Lynx. You can bolt on a SmartShunt like this. In my previous video, I just had the SmartShunt running right into the distributor, and I did not have the Lynx Shunt. So as you can tell, I've got the negative battery cable running through two separate shunts, and I've got them both wired into the GX device, and they are both reporting their data. So what we want to do is go ahead and zoom in. I'm going to show you how to select which battery monitor you want as your main battery monitor for the system. But before we do that, if you're interested in your overall system, not just your battery monitors, then I want to mention a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of the 3 major charging sources that you're going to find in van and RV power systems, which are solar, shore, and alternator power. It's going to talk about how they each have strengths and times when they excel, and then times when they falter. But when you bring them together in a holistic power strategy, it's going to make sure that you're covered no matter where you go out on the road, so you can enjoy what you're doing out there and you're not going to be worried about your power system. There's also a discussion about different battery types and the strengths and weaknesses of those. Internal BMS batteries and external BMS batteries like the Victron Smart Lithium. It's going to make a comparison and show you the pros and cons of each type. And then lastly, there is a really cool diagram that's going to show your entire system design, kind of like you have here. It's going to show you how the charging sources come in at the top, how they make their way through the system to charge your battery bank, and how that power gets distributed to your end devices such as your air conditioner or your microwave. For instance, how does the alternator power make its way through and come out and run your air conditioner? So it's a really illuminating diagram that's included with the Ultimate Van Power cheat sheet. To get your own copy, all you have to do is click that link below or go to rosslukman.com/vanpower. All right, with that, let's go ahead and zoom in on the chrono screen, and I'm going to show you a few more points. And I've also got kind of a revelation that I want to share with you. So as you can see, I've already assigned one of our battery monitors as the main battery monitor for the GX device. So let me show you how I did that. We're going to click on the screen and go to Menu. You can see our device list is bringing in the Lynx Shunt as well as the SmartShunt there. But let's go down to the settings and where it says System Setup. And you can see here it says Battery Monitor. And it has auto-selected the Lynx Shunt. And it's set to automatic. But let's go in there and you'll see the list. And we can select the Lynx Shunt or the SmartShunt. Or as it's done, we can have it automatically select one, which is typically what it does if you only connect one battery monitor, but we're doing something kind of strange today with our two battery monitors. So automatic is not always going to work, but we can just click on the Lynx Shunt. It's going to select that, and that is what's going to display on the main page. So let's go into the Lynx Shunt and look at a few of the settings. We're just going to click on it here. And as I mentioned before, we have to program it in the GX device. You can see we've got some data coming in at the top, our temperature, our state of charge, which I did reset to 100%. But basically, this is all of our data. It's going to tell us what our relay is doing, if we have any alarms. You can see the list of alarms is somewhat extensive. Low and high temperature for the battery, low and high battery voltage, low state of charge. It's going to go off if the main fuse is blown, things like that. But let's look at the settings. So we actually have to give it some settings for the battery bank. We have a 100 amp hour battery. The charged voltage is going to be the bulk charge voltage from your battery manufacturer. 14.5 works well for the lifetime batteries. And it's going to use these first three parameters in order to reset to 100% state of charge. So what this means is when it gets below 3% of tail current, which would be 3% of 100 amp hours here. So below 3 amps, when the battery gets up to 14.5 volts and it sits in that condition for 3 minutes or more, it's going to reset to 100% state of charge. Before it does that, it's going to keep an accounting of what's coming and going out of the battery bank through the shunt. So it's going to give you that real-time data, but every once in a while, it's going to reset to 100% when you get the battery bank fully charged. Now, Peugeot exponent and charge efficiency, these are set by your battery type, and I've entered some numbers here which are typical for lithium batteries. You're going to want to check your manufacturer for those as well. And we have additional data here. You can see where I synchronized it to 100%. And that is the battery settings for the Lynx Shunt. And you can go into alarms. We've got that low battery voltage, high battery voltage, low temp, high temp, low state of charge. We can tell it to go off and trigger an alarm with all of these various parameters. And then on the relay, we can tell the relay when to go off. So we can have it go off with an alarm. We can have it control the generator start or stop. We can do the manual control where you just click the button and turn it on. You can hear a very muted click over there as the relay goes on and off. So that is the relay, and then you can reset to defaults. So that's all the programming that you're going to do in the Lynx Shunt. With the SmartShunt, all of that is going to be done in the Victron Connect app, which I showed earlier. I'm going to zoom back in just a minute. I have a couple more things to share with you, but I have also kind of a plot twist in the story here. So the end of this video originally showed that the SmartShunt voltage measurement is a little bit more accurate, and its battery temperature sensor is also more accurate. Basically, it shows the correct voltage and the correct temperature for the battery, and the voltage reading on the Lynx Shunt is about 0.05 volts off. Not too much, but I noticed it was a little bit off. And then on the temperature sensor, I ran it over here. I ran different sensors, shortened the wire, put it on negative, put it on positive, but no matter what I did, it was about 5 volts or 5 degrees Fahrenheit too high at normal room temperature. Now that changed. I used a butane torch and I heated up the battery terminal, and I had both temperature sensors from the SmartShunt and the Lynx Shunt on the same terminal. Heated that up and I looked at their readout. And at some point when it got up to 115, 120 degrees, the temperatures where it really matters, at some point the SmartShunt did pass the Lynx Shunt when you got to those higher temperatures. So it's a little bit inconclusive on the temperature sensors and which one is more accurate. I can tell you at room temperature, the SmartShunt is dead on, and that one is 5 degrees too high. So it could throw us off a little bit on if we're setting alarms. The final thing that I found though, I took the original video down because I'm drawing a system design for my students that includes the Lynx Shunt, and I had to know after I made that video, I said, do I need to quit recommending that item? And so I decided to do further testing. I had this display sitting here. I didn't have to film anything else, so I played around for a couple of days and ran some tests. I turned on the stove as a load. I turned on the charger, ran power in and out of the battery through both shunts. And what I found was the current measurement on the Lynx Shunt is more accurate than the SmartShunt. And then further, what I found was that when I charged the battery all the way up, I synchronized both battery monitors to 100%. I turned on the stove and I let it run the battery all the way down. I think to 27% was the lowest I got. But I just let it run and run and run and run. And the state of charge of both battery monitors was within 1% of each other. So the state of charge went down and down and down. Now I know with a 1,000-watt stove running, we had 95 amps running through this line. There was a voltage drop between this monitor and that monitor. However, with a current measurement, it's an absolute number. With Kirchhoff's law, current law, the current through here has to be the same as the current through there. It's a law of physics. So I was able to compare the reading on the screen, which we'll do in just a second here. And I also had a third-party multimeter. This is a Blue Sea 8110 multimeter. And I'm able to clamp on any of my lines and get the current that's running through there. And so I had kind of a third-party instrument to check my currents that both of these devices were reading out on the screen. And I found that the Lynx Shunt had a more accurate current reading. And then as far as the voltage, I just measured here for the SmartShunt, and I measured here for the Lynx Shunt and compared it to what the readout said. And that's where I found that this one was 0.05. This one was pretty much accurate. That was 0.05 volts off. But as I said, once the calculations ran, one was more accurate on voltage, one was more accurate on current, and voltage and current are multiplied together to get your amp hours being used, and the state of charge, pretty much they were neck and neck. It was kind of a wash at that point. So I still recommend the Lynx Shunt. I'm going to go ahead and finish the system that I was drawing for my students. And I recommend both of these. And what I'd like to do is show you a little bit more of a nuance of what I'm talking about, just so you can see what I'm saying here. So let's zoom back in for just a second. Let's look at a couple more details. So on the voltage, you can see it says 12.89 volts on the SmartShunt. And I can tell you that that is what the multimeter will read out if I measure the SmartShunt terminals between battery positive and the SmartShunt. We'll get about that voltage. And then if I go down to the Lynx Shunt, there's no current flowing right now, or very little. So the voltage at the Lynx Shunt is actually going to read out the exact same as the SmartShunt, but the Lynx Shunt is reporting 0.05 volts less for the same voltage. So it's a little bit off on that. And then when we look at the temperature, the SmartShunt is reading 72 Fahrenheit. The battery has acclimated to the room temperature here. The Lynx Shunt is reading 77. So SmartShunt said 72, Lynx Shunt said 77. I can tell you that it is 5 degrees too high for the Lynx Shunt. And you would just want to keep that in mind when you're setting any alarms. You may want to have some kind of shutdown alarm and based on battery temperature, and you would just want to take that discrepancy into account. But it may not be a huge consequence, and also when you're calibrating these battery monitors, sometimes you do have to come back and change the settings a little bit and really dial them in. So it's not unheard of here, but I wanted to point that out. Now the current, what we're going to do is turn on the stove. I'm going to do that off camera, but I want you to look at the amperage here. Let's go ahead and turn on the stove. You'll see the amperage numbers climb. And what I found was the amperage on the SmartShunt is actually a little bit lower than actuality, and the Lynx Shunt is more accurate. So, and you can start to see the voltage drop with the Lynx Shunt further away from the battery. It is receiving less voltage. So this is what happens at high currents. The Lynx Shunt in my system is theoretically not in the right place. It needs to be closer to the battery, and that's why we're seeing that discrepancy between the voltages there. But we're looking at the current. The current should be the exact same regardless of where those devices are in the circuit. The current running through them should be identical, and you can see that they're a little bit off, and I can tell you that the Lynx Shunt's current is more accurate. If I take a reading, I'm going to zero out my clamp meter. We're at 96.8, 96.9 amps. So this is 96.4. So this is almost 2 amps off. This is within 0.3 amps. It's still not the same as the multimeter, but it is a couple amps higher than the SmartShunt. So this is off, this is more accurate, and that is going to have an effect on your calculations. Calculations being state of charge and how many amp hours you've consumed, etc. All right, before we cut this off, I just want to mention we're at 104 amps and 106 amps. The multimeter is telling us 107.8, 108.2, 107.7. So we ran our battery completely flat. We'll go ahead and end the test with that. But that's a low battery alarm that you can set up on the GX device from either one of these battery monitors. But I would recommend going with the battery monitor that goes with the system that you want. So if you're going to use a Lynx Power In and you would like to use the Lynx system, I think that the Lynx Shunt is a great option. If you're looking for something a little bit more simple, maybe you want to use the Lynx distributor, but you want just a simple battery monitor, I would go with the SmartShunt. Now I know they are different sizes. We have a 500 amp unit here and a 1000 amp unit. They sell this in a 1000 amp unit, but the 500s are typically all I need for my systems. At 12 volts, that's going to give you up to 6,000 watts going out to your system, and that is above and beyond what most of my students need and most of the vehicles that I work on need. The 1,000 amp unit will give you up to 12,000 watts at 12 volts. And with the Lynx system, it's a little bit heavier duty. It's all built for 1,000 amps. Most of the components are 1,000 amps. And it is what it is. It's going to have that thicker copper. You're going to have a little bit less of a voltage drop, things like that. But that is a little bit more of a feature-rich item than the SmartShunt. As I said, I think that's appropriate if you're going to go with the Lynx system. If you don't want to go with a Lynx setup, I think the SmartShunt is a definitely tried and true item as well. And I was a little bit surprised by their accuracy, inaccuracy in some level, but I think that we're within 1% of our calculations, and in general we just need to have some indication of what's left in the battery bank so we can make decisions and take action. And so we really drag these through the mud and put them through the tests, but I think that they are both good options, and hopefully the video gave you some things to go on choosing which one is right for you. Now, if you want more information on your overall power system, be sure to pick up your copy of the Ultimate Van Power Cheat Sheet. Just click that link below or go to rosslukman.com/vanpower. So thanks for watching, and I'll see you in the next video.